Welcome to the Intersecting Us podcast, where math and life intersect.
In this podcast, Brian and Dave raise some interesting questions about the nature of the universe, whether it had a beginning, and what's our place as humans in this gigantic space we occupy. The goal is for it to be a thought-provoking discussion to encourage you to ponder the mysteries of the universe.
Today at Intersecting Us, we're going to continue on this idea of finding patterns in math and in nature or life. Today, we're going to talk more about the life part or creation, physical things, maybe even some non-physical things. It's a bit amazing, like math, that the universe that we know and the universe can be defined in a number of different ways. But we're talking mostly about the physical part of the universe that we see, the celestial bodies, the light, all those types of things. It's interesting that is quantifiable for us. We see patterns there. It allows us to do certainly a lot of science because things are repeatable and they're measurable. But what we're going to look at today at the Intersecting Us podcast is more about what difference does it make that it's got a pattern, how that might intersect with math, and how that helps us to understand our world and our life. And then maybe ponder a little bit, maybe what our personal thoughts and feelings are. That's part of what we want to do here is we want to talk about math. We want to talk about life. But no matter if it's math or life or anything or nature, somewhere it does get down to what does this make any difference to me? How does this change my life? And so the concept we have, and Dave's here along with me, the concept I'm thinking about is the fact that really up till the 20th century with Einstein and a few other scientists, most scientists that thought about it believed that the universe was eternal past, that it continued on into negative infinity, if you want to use the math term. But then we found out, because of being able to measure things a little better and seeing a lot of sometimes autonomous ways of measuring, that it had a singularity. It started at a particular point. So what I want to start out today, and I've got some thoughts about that, but I'd like to bring Dave in. I know he's our math guy, but I think he's got more philosophy in his mind than he knows. But what does that, I'm not going to ask you the psychological question. How does that make you feel? Maybe we'll hit that later. But what do you think of, what difference does it make, however you want to put that, when you think of the difference between those two? Believing that a matter, physical universe has always been there, or believing or knowing that it had a start sometime? What difference does that make?
To me, it's just a fascinating question. Just to think about, I remember as a kid, very young, thinking about like, where did this all begin? How did all of this life get here? Because we have something, and something had to start that. And where did that begin? So first of all, where did stuff come from? And then the whole idea of time, going backwards in time, what was the beginning? Or if there wasn't a beginning, how do you have an infinite start? And neither one of those ideas really made sense to me, that there was a beginning or there was an infinite beginning. I had a difficult time getting my mind around both of those ideas, but they were very fascinating to me as a kid. And as I've grown to an adult, I still find it just fascinating. And I just really enjoy reading about it and hearing the advances that scientists are making, and seeing, you have new technology. Where are things heading? Because what a cool question to be asking.
Well, and I think as we talked in like our last podcast, when we were talking about the natural log, how that had more than one person that came to some conclusion about it. So that shows that it has reality to it, because you can come at it from different ways. And that's what's happened with this, so many different scientific things. But when I think about it, you think about how we always do this with kids or whatever. When you talk about infinity in math, it's like, what's the biggest number? And of course, you always add one. Well, you can do the same thing the other direction. What's the smallest or the most negative number? We'll put it that way. Well, you can always subtract one and keep going. Well, that's what we're saying here. not just philosophically, but in reality, that you can't do that to the universe. There is a time when you've met the negative. And as I've looked at it, I've looked at different cosmological books and not philosophical books. But last I looked, it was, and I've seen 14.6, but the last I looked, the different ways between 14.88 and 14.89 billion years is how old the universe is. The Earth being, 4.7-ish billion, give or take a million here or there. I think when you look at that, that's a little different than math. It's easy for us, I think, to look at infinity in math or eternity. A little harder when you're getting into the universe.
Mm-hmm. Right. And of course, I'm going to have to throw out that big idea that we came across in our video where we took the area under the curve of e to the x and we started at negative infinity, which, what does that really mean? And then we took the area all the way up to 0. So we took all of the negative numbers into account, and the area of that curve is exactly 1. And so, Brian, us math people, we've figured this negative infinity out. So you guys have a lot of work to do to catch up with math folks who've made sense out of negative infinity and decided that we can take all of the time in the past and sum it all up, and apparently it all equals 1 if we take the perfect curve into account. So that's pretty cool. But, today, though, we're talking about kind of like what that means for life. But lo and behold, there is going to be some math involved. So don't think that we can't talk about math today.
Well, I think the math is good, but, that's the geeky mamby-pamby world where it doesn't really bring it into the reality. Sometimes, we talk about in-dimensional space and all those things. Very helpful. You got to use if it wasn't for math, we wouldn't know 14.89 if that's the right number a billion years ago. So it's always helpful. It's always helpful to have those things. It's just, how do we get it into the real world? Because what you start getting into when you talk about, you start getting it. It's not just math. It's not just science. It's not just patterns, although important, because the universe, the fact that we can do a lot of the things we can with our technologies because we can repeat the patterns. But now we're getting, people have dogs in the hunt there, as they say. The ideology changes. It makes a difference for our existence when we start thinking, if it is eternal past, then that means the universe, the physical universe itself, is an entity that is always there and is a foundation and is the thing everything comes from. If it's not, well, now going kind of back to the math idea, what was there before? What we call, I guess it's been called now, I called it the singularity. What happened? There was all the matter, apparently, and I'm not a scientist. So if you're a scientist and you want to comment on our website, you can go there and figure out how to do that. intersectingus.com. Correct us. Certainly, I'm not trying to be too scientific about it, but whatever was there, the matter, we say it went bang, and we call that the Big Bang. And that was when, and I get somewhere way under 1 second, everything started going into motion. And that's what we measure. And we measured it backwards. And that's how we got the singularity. But that's cool. That's cool when we look at science, and it's cool when we look at math. But what difference does that make? What does that mean for the way I look at life and existence and eternity when now it got started? Mm-hmm. It got a start to it. Mm-hmm. So now the question asked, we're going to get into a little bit of what we call causation and effect. That it went bang. It seems like right now the scientific consensus is it did. It went bang, and that's how we can measure it. And this is a rabbit trail, but sometimes you want to go down those. We may or may not get back to this. I'll just say it, and then if we get back to it, maybe in a future podcast, but probably in a future podcast. When you look at the fact now, it's not only on the negative end, if you're looking at it in a math way or the past, it's also the future. Because what we've got the idea of entropy now, things, breaking down over time. You've got, nuclear half-life, and everything eventually deteriorates to, heat death. So now we're not, because of this, if it's not just the eternal past that we're worried about, now we can start thinking about our future. And because of this science, now the universe is not only going to have a singularity that starts it, it's going to die in heat death eventually, if that's all there is. Mm-hmm. And that starts now. It might be billions of years from now, but it means that we as a people, as a human species or whatever else we have is going to not be here forever. You know, so where in the old version with everything, if it was eternal past, you can make a case it's eternal future and you'll have those questions. Mm-hmm. So now we're getting into, okay, what about me? And you can bring that down a little bit, but bringing it back to the back thing, what caused it? I don't know if you have any thoughts on that, either mathematically or just thoughts that you have, Dave, about one of my favorite lines I've heard from, I can't remember who it came from, but it's not mine. A big bang needs a big banger, you know. And I think, what do you think about that? Is that, or do you think I assume you do, but give me some thoughts there.
Well, sure. You know, for me, I mean, this is my own personal perspective, but there's a huge universe out there. There's even the Earth itself is really big, and it is easy to get lost in all that bigness. And for me personally, I think about, you know, was there some being that created it all? And if so, what kind of creator is that? And for me, I've been given, I guess, a lot of peace about that. I do believe that there is a creator out there that is in control of it all. And so that it kind of takes away a lot of my worrying about the future, all these things that I think are legitimate questions that you have, Brian. And I do not know the answer to them, but I'm not worried about them either, because of my own personal belief that the creator that started it is also in control of the finish. And it's almost as simple as that.
Well, I think that was good because you just can't realistically, or if you're being honest, not start talking about what it means to me, because, you know, you can talk all kind, you know, maybe a good analogy would be, you may be a scientist that works on different ways to stop viruses from harming humans. And so you work on that science, and it's meaningful and it's good. And I think it has, you know, it's interesting. You're trying to find innovations. That's good. You're understanding the virus and the RNA and the DNA and all that kind of stuff. But then you find out that the particular virus that you're working on, your kid has. Mm-hmm. And if you can't find a cure within a short amount of time, they're going to die. Mm-hmm. Well, that changes your research a little bit. You know, It doesn't change the math. It doesn't change the science. It doesn't change the patterns, but it changes the old term, your heart, your emotions, your drive, what makes you want to do it. You might work another hour of overtime. You know, it changes. That's it. This stuff gets personal really fast when you do that. Now, when we're stepping back to something as big and we're talking billions of years and all that, sometimes it's hard for us to do that. But we were both actuaries at one time. You still are. We do deal with mortality in actuary, and you obviously, you know, morbidity and all those types of things. Even though the universe has some billions of years left, as far as we know, unless something catastrophic gets into the system that we don't know of, we don't. Mm-hmm. And that's the thing you start doing, and this was what philosophers do, is you start thinking, okay, the universe had a beginning. I had a beginning. Mm-hmm. I physically had a beginning. And, you know, we'll get into later podcast about thinking about, are we meat all the way down, you know, physical? Is there some sort of a non-physical component to it? Which, note to self or to everybody listening, that might have something to do with the bang too. I mean, at least we have to start thinking about those questions. We will do that in a little bit here. But then, so that's the beginning. And then, so if the universe is going to die, well, that's a long time, most likely long time will be gone, but we have an end, and that is something we will talk about in the future, but see how it so quickly gets into reality about our own selves. And one of the things we want to do at Intersect, yes, we're trying to intersect math and life. That's what we do. That's the big concept. And we don't necessarily want to tell you what to think. We're just throwing out some concepts here. As you said, I think very early in one of our podcasts, that we're not always going to find the answer. That I don't even know if we're looking for the answer. We're just trying to ask better questions. But we do want to find at least some temporary or temporal answers to our own life, and maybe have a little bit contemplate, because we're, you take 1 billion, you nod that down. And I remember back in actuarial science on our mortality tables, we always ended at 100. Well, why did we end at 100? I mean, if you were in life insurance and somebody lived to be 100, you just gave them the death benefit. You're dead. Statistically. Or we'll throw it in an annuity for you if you want. But why 100? Well, that's because that's kind of about the most, once you get past 100, you don't have a lot of people alive after. Well, that does have to make you think a little bit about eternity. So when you come back to the idea of the Big Bang, it's going to have more than it's not just a scientific question, although it is. And I hope both of us, you and I, Dave, isn't the goal to find what's true?
Absolutely.
What is the truth? We've all got a dog in the hunt. We all have ideologies. We all have presuppositions about how reality works. And hopefully a lot of those presuppositions are true. But we have to sometimes you can't find the truth. Think about it. How well would have Kepler been able, and maybe you can talk a little bit about Kepler and a little of the math of it. How well could they have done, or Copernicus, if they believed the earth was flat? If that was their presupposition. Or that the sun was revolving around the earth and the earth was in the center. What difference does that make to the science?
Yeah, they had to get the math right. And as human species, we've made some pretty embarrassing mistakes over time. And I'll throw all kinds of people, are in that category. I know the church certainly is one of those groups that has made some poor judgments and decisions, to say the least, regarding the science of the world. And so I think there's this idea that it brings us all to a very humble state when we're asking these questions, because we only have limited information and we're doing the best we can with it. But it is good when you see people like Kepler that are out there and they're saying, okay, I'm going to look at what is true up in the skies, and I'm not going to just take something as true just because maybe someone else says it is, when I can look at facts and then, see, well, this is exactly what is going on in the universe.
Well, and you think just back to the base thing we're talking about. Is it true? And I know philosophically you had to find truth. I guess for us, we're going to go with the correspondence view of truth, that what corresponds to reality. There's other kind of ways to look at that. And we're looking at what we would call objective truth. It's just, if the universe is 14.89 billion years old for me, it's also 14.89 billion years old for you. That's objective. Subjective is, well, I might live to be, 79. You might live to be 83. Well, that's different, but that's because it's a different subject. So we're looking, is it objectively true that the universe had a beginning? We want to get that right. And we do look for certainty in science. We do look for certainty in life. But I have come to find, as you read philosophy, as you just read novels about fiction, just life, certainty has a psychological quality to it that we sometimes forget. Am I certain that, we always use the 2 + 2 = 4, or, all those types. And well, yeah, because that's not really a philosophical question. But maybe we could ask, am I certain that the universe had a beginning? I think it's better for us, and this is where the philosophical terms come in. Instead of saying 100% sure, I'm as sure as I can be, or as certain as I can be, given the evidence that's there. Mm-hmm. Given what I've been, and I'm not a scientist, but that's the best you can do. Think about the logic of this. Let's put percentages on. I like to do that. We always like to do this. I always like to know what the percentage chance that the Cardinals will win tonight, which keeps getting lower and lower this year. But that's another question. We'll get into that in a different series, right? When we get into maybe some athletic stuff. But maybe I say I'm 99% certain in my mind that the universe had a beginning. So I'm 1% uncertain. Is that 1%, does it logically follow that I should operate my life on the 1%?
It doesn't seem like that would make sense.
Yeah, that would be, I think, would be stupid, right? I mean, that's just, no. You still operate on the 99%. Mm-hmm. And maybe you can put 99.9 and you can put whatever you want there. As it gets closer to the line, the infinity line, like we talked about last time. We operate sometimes on not 100% certainty. Are you going on a trip in a plane anytime soon, or do you know of? I guess we had some friends that went. Anything offhand? Or have you recently got on an airplane?
Yeah, I get on an airplane once every quarter or so. So yes.
Yeah. So are you certain that airplane's not going to crash?
No, I'm not.
Yeah. Well, it kind of depends on what you mean by certain. Again, don't you? You have evidence that it won't. And of course, you get that quote that everybody gets. It's the idea that, well, don't you know, you're going to be safer in the airplane than you would be in a car. And it's like, yeah, maybe that's true. I mean, I haven't looked at the math or the statistics of that. But you're certain enough, aren't you? Mm-hmm. Or you wouldn't get on it.
Mm-hmm. Right.
If you were 90% certain that sucker was going to crash, you wouldn't get on it. And I think this is the concept we have to think about, especially when we're talking about science. We might have a theory of science, and sometimes we'll kind of get mad at the scientists because it's just a theory. Well, it's a theory that we're as certain as we can be given the data. Mm-hmm. The theory of relativity. Are we 100% certain that's true?
Well, speaking of which, we talked about in a previous podcast how the theory of relativity was still being developed, and it looked like everything was in place from a physics perspective, but from a math perspective, the numbers just weren't adding up. And it was because Einstein was using Euclid geometry, which we were, quote, certain was the correct geometry because it was the only geometry in town. And of course, it had survived 2,000 years. And we all know it was true until we found out it wasn't. Now, does that mean Euclid geometry is not true? No, Euclid geometry is true if we assume the 5 postulates are true. And the 4 are kind of considered the foundation to what they call kind of like generic geometry. But then it's the 5th one, the parallel postulate, is what we must assume to be true in order for Euclid geometry to be true. But then Einstein, his truth was, well, I need this to work in the real world. And then that required Riemann's geometry. And so even within the Euclid geometry, solid, this is 100% true, there's a caveat that it must be assuming based upon the assumptions that go into it. So I think that's one of the things you have to look at is what assumptions are even starting with.
Yeah, and in philosophy, we call those presuppositions. Uh-huh. In math and science, obviously, it's just assumptions. But I think that's a good segue as we kind of wind up here, is the idea of we know, for instance, at the quantum level, and there's a lot of research being done on that things don't work necessarily the same. We're not completely sure, but we're looking for the truth there, and we're not certain. There's different theories of how that works. But then you go back to the singularities stuff right at the Big Bang, that less than a second time, that it seems like the Newtonian physics, it works a little different. That's the only thing we can make sense of. And we're still kind of working through that because that's obviously a quite past event. But that's the idea. What I'm doing, and a lot of people have done, is don't go to the singularity, go prior to the singularity. What math, what ideology, what reality, what truth, maybe we want to use that, works there. And we'll kind of sum up that, here as we end the podcast in the next few minutes. It's that age-old question that we've already posed, I posed out there about, is the universe all there is? Is the physical universe all there is? And I'm hoping that as you listen here, that it's hard to do. We all have presuppositions. I realize that. And the best thing to do is have another honest person that calls us on them. Because I know the presupposition is up for a lot of people that it's all material. And there's other people that have presuppositions that it's got a non-material and a material. But hopefully we can all say, we want to know the truth. And this is objective. It really doesn't make sense logically, does it? That for me, I'm part non-physical and part physical, and so is the universe. But for you, you're only physical, and so is you. That just, you can't have, that's the law of non-contradiction. Just doesn't make sense. So the question I kind of want to leave out there, and we'll most likely hit this in future podcasts, is how did the Big Bang get banged? Was it, what caused it? And really, what you try to do is you try to find, get rid of the middle. Just do a binary as best you can. This or this. And I think we've done that philosophically. Something or nothing. That's really all that's left. Because if we're talking about something that got the universe started, so we're not even talking about the bang, but the stuff there to bang, the physical stuff to get there. What makes the most, and obviously we're still talking about it. We're trying to find the truth. Is it something or nothing? And both of those are out there. Logically, we have to see what is possible.
Right. But it's not both and it's not neither.
Exactly. That's what you try to get. Now, that's an interesting category. And if we decide it's something, well, we've got some options out there. And that's the big stuff going on right now, both philosophically and scientifically. If the answer is not nothing, so it's something, what's the something? And can we find that out? And are we willing to give up maybe some of our presuppositions to find the answer? What is true? A lot of people are saying this is true or that is true. And good luck being 100% certain at this point, at least with the data.
Right.
I think when we bring certainty down to the psychological and personal level, I think people are almost 100% certain, or at least they live their life that way.
Right.
So I think I hope that helps. You have anything to add there before we finish up there?
Yeah, I'm going to throw out a little math nugget for those math enthusiasts out there that want to see where does math play in all this. And so from the stuff I've been listening to and reading about cosmologies, they are trying to figure out what is the shape of the universe. So that is a question out there. The simple thing that we maybe think about if we haven't studied that is we're like, well, it's 3-dimensional space. Einstein came in and said, no, it's 4-dimensional because you got to add time. When they get out in the universe, they're not sure what is the shape of the universe. And so just stop and think about that. What is, because we can think of a sphere, but what about a sphere that goes on? A sphere has a limited boundary. That's what makes it a sphere, is that the distance from the center is the same for all points. And so is the universe something like a sphere? That is like a simple shape, but there's all kinds of interesting ideas that are out there about what is the shape of the universe. And they're looking at the data, of course, looking at the stars, seeing how they move over time to try to get wind of how this universe is created. But that is just something to marvel at, I think, and appreciate the universe that we live in, is that there's a shape out there we haven't figured out yet. but it's a big mystery, and it's likely going to be something that's not simply like, oh, a simple sphere. And so just kind of appreciate the complexity and the beauty of the universe, and also the math behind it. The answer to that question really lies in topology. And topology is an entire branch of mathematics started in the 1700s by who else? Euler, who started topology. Yeah, we don't have time to get into it, unfortunately, today about what all it is, but topology is just started out as a simple idea of just studying shapes. And now all of a sudden, scientists are saying, hey, we can use that math to figure out what is the shape of the universe. And so it was just kind of like fun theoretical stuff at the beginning. And now it's turned into something really serious.
Yeah. So, that's a good way to end there. I think looking at the different, that's part of what we're doing here. Our belief, our presupposition, maybe we could say, is that we're never going to run out of things to talk about, because the ideas and the concepts, whether it's mathematical, philosophical, ideological, even theological, you're not going to exhaust this. So if you're bored in life, if you are someone who looks at life and don't think there's new questions or we've discovered everything, I would encourage you to get on our website for one and look at some of that stuff, intersectingus.com, or come to our podcast, watch our videos, and start asking questions. Hopefully, one of the things we want to do is hopefully you get to know us a little bit through our podcasts and videos, but maybe we'll get to know you a little bit with some of the comments that you can make. So for today, we'll end with this, with the idea that we're kind of just sitting there with that question. Did something start something that we have, the universe, or did nothing start it? We'll pick up that again, and this is a question that we're going to continue. But hopefully, Intersecting Us will help you, not just intersecting math and life, but maybe intersecting some of the most important questions about universe and objective truth into your life, and making a difference, and maybe giving you a little bit of contentment and joy.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.